Good afternoon.
Good afternoon.
So how's everyone today? So are we Hannah-less today?
No, she's here. She's just not in here yet.
Okay. All right. So, but she will be coming.
She's right here.
Oh, okay. All right. Let's see. I'm having a little trouble with loading my lesson here today. Let's see if I can get another shot at it here. Okay. So let's see. We've got Winslow. I guess, are we all there in St. John's? Okay. So, does anyone have anything amazing they did over the weekend? Want to hear about it?
It looks nice.
I went to Telluride this weekend.
Where is that at?
Colorado.
Oh, okay. So how was that?
It was good. It was snowing.
So is that like a place to ski?
Yeah, it's a huge ski resort. I didn't ski because I woke up kind of late, but it was fun.
You went all that way just to sleep in? What the heck?
Yeah.
Well, that's cool. So anybody else do anything amazing over the weekend? Come on.
We had a robotics competition at state and we placed third kind of overall.
Third kind of? So do you qualify for the next round?
Unfortunately not, but we get to go anyway and
What?
volunteer, so.
Now that kind of stinks. I mean, in the Olympics, if you're the bronze medalist, that ought to count for something, right?
Yeah, I think it should, but it's all right.
Okay. Well, yeah, I think one year, with robotics, they were like telling me that we had to win. Otherwise, the school wasn't going to pay for us to go to the next round. I thought that was kind of crappy, but whatever. I guess it's the same thing with, sports or something. You have to win to go on the next one, so I guess. But anyway, anybody else? Well, I saw the Utah Shakespearean Festival do Romeo and Juliet. And I love Shakespeare. And so that was really good. It was very different than anything else I'd done. It was actually the actors played high school students doing Romeo and Juliet in their English class. And so it was really kind of cool because Romeo was played by, this nerd in a Star Wars shirt, and he wasn't necessarily the best looking of the group. And so it was kind of a nice little twist to it. I really liked it. And anyway, it was kind of fun. All right. Well, any questions, comments, concerns before we get started here today? All right. Well, our plan is to do 8.3 today, which is on trigonometric integrals. So the idea here is to use trigonometry to set up some formulas. That's really what the next two lessons are. Okay, so this one I kind of like in that it's like a pattern, and this and the next lesson to me are two of the reasons why I love doing the student success organizers, is because it really helps me organize. There should be teacher success organizer too, because it really helps me organize things in a way that I never had as a student. So with these trigonometric integrals, what we're talking about here is integrals of this form. Okay? So that's the first blank, because the whole front page is all about these. The integral of sine n of x, cosine n of x. So those are the type that where we have exponents on sine and cosine. Okay? Now, there's actually 3 different cases that we'll look at. Okay? So case 1 is if the m is odd. Okay, so what we do is we write m, so the exponent as 2k plus 1. And then basically what we do is we peel off one of the signs. And so then all of the even powers, sine squared, sine to the 4th, or whatever, we write those as 1 minus cosine squared. And then, so then what happens is we have everything in terms of cosine except the one sign that we've peeled off. And then we do u substitution where we let u be cosine x. Because then the one that we've peeled off is the du. Okay? So, but this is kind of our goal here, to get everything in terms of cosine except for the one sign that we've peeled off. Okay? Then we'll do u substitution. So let me give you an example. So you just kind of watch this first, and then you'll see it's not going to be difficult. So here where we have sine cubed x, all right? So that's case 1, where the exponent here is odd. So what we're going to do is peel off one of them, so sine x, and then all of the even powers. So here we have sine squared x. We're going to write that in terms of cosine. So that's going to be 1 minus cosine squared x. Okay? Now, what we're going to do is if we let our u be cosine of x, and then du is negative sine x. Okay? So what we need is a negative here with the sine x that we don't have. So negative sine x dx. So that's where the green, I'm putting a negative in here and a negative out front. Okay? So now we do the u substitution. So 1 minus cosine squared is 1 minus u squared. And then this other cosine squared is another u squared. And then the negative sine x dx is your du. Now, before we integrate, we want to go ahead and multiply this through so we don't have to do integration by parts. So we'll just have u squared minus u to the 4th. And now we can integrate that using the anti-power rule. And so that would be negative u cubed over 3 minus u to the 5th over 5 plus c. And then remember, u is cosine. And so when we distribute the negative, plug in the cosines, that's it. Okay? All right, so I'm going to leave this up. You try practice 1. All right, so Skylar, what do you have?
I'm confused.
Okay, so this is the case where the exponent on the sine is odd. Okay, so what you do is you peel off one of those, and make it sine squared times sine. Okay? So then the sine squared, you're going to rewrite that as 1 minus cosine squared. And so now you do your u substitution. You're going to let u be cosine x, so du is negative sine x dx. Okay? So what we need here, well, let's go ahead and put in the negative here. So we're going to put in a negative there and a negative out front. So then when I do the u substitution, I'll get 1 minus u squared, and then negative sine x dx, that's my du. So then now I can integrate. So the integral of 1 is u, minus the integral of u squared is u cubed over 3. And so now I'm going to distribute the negative and plug in what u is. So minus cosine x minus a negative, so plus cosine cubed x over 3 plus c. All right, any questions on that? All right, so case 2 is where the exponent on the sine is even, but the exponent on the cosine is odd. Well, then we do kind of the similar thing where whichever one is odd, we peel off one of those. And so then the even powers of cosine square, so cosine squared, cosine the fourth or whatever, the even powers will use this trig identity to write all of those cosine squares as 1 minus sine squared. And then the cosine that we've peeled off then, we'll use that to help us do our u substitution. So then this time our u will be sine x, and so we'll have everything in terms of u. And then our du will be cosine x dx. So you keep an eye on these guys, Mr. Tomlinson?
I'm trying to.
Well, these two make you look really good. I'm going to tell you that right now.
Good, because I don't look good on my own.
Well, you know, at some point you have to exchange your good looks for like smart. So,
Yeah.
you know, when your brain starts pushing out of the top of your head and starts knocking out your hair follicles, what do you do, right?
Yeah, exactly.
So,
Let everybody else look good. We got some good students here. I'm glad to see them doing well.
Yep.
Thanks for all you do. Appreciate you.
You bet. Thank you. All right, so just watch this example. All right, and then we'll have you do one. Okay, so here we have cosine to the fifth. So because this is odd, then we're going to peel off one of them. Okay, and so we're going to make it cosine to the fourth, or cosine squared squared, and then I'm going to have one peeled off, cosine x dx. Okay, so now this is going to be part of my du. So just let it be. All of the even powers of cosine, we're going to put those in terms of sines. And then if we have extra signs in there, we'll use those as well. So cosine squared is 1 minus sine squared. So it's 1 minus sine squared squared. Okay, but that's okay. So now we have the 1 peeled off. So I'm going to use oops. So I'm going to have cosine be sine will be my u. So u is sine x, du is cosine x dx. So now I'm going to write everything in terms of u. So this will be 1 minus u squared squared, and then the cosine x dx is your du. Now, before I integrate this, what would I want to do here to make the integration easier?
Multiply 1 minus u squared by itself.
Right. So just multiply this out. So that'll be 1 minus 2u squared plus u to the 4th. All right, now we're going to use the anti-power rule and integrate. So the integral of 1 is just u. Minus 2, and then u to the 3rd over 3, plus u to the 5th over 5. Add 1 to the power, divide by that new power, plus c. Finally, I replace the u with sine x. So I'm going to get sine x minus 2/3 sine cubed x plus sine to the 5th x over 5 plus c. And that's my answer. All right, any questions on that? All right, so let me scroll up, and then you guys use this to help you through practice 2. All right, so Chloe, when you've got it or if you get stuck, let me know.
I'm not totally sure if this is right or not, but I got sine 3 to the, or sine to the 3rd over x over 3, and then sine x minus sine to the 3rd x divided by 3 plus c.
Okay, so right here, you're going to want to multiply those through
Oh.
before you integrate, because remember, there's no product rule for integration. So you can't just integrate these separately. So you distribute and then integrate. All right. So, yeah, so next to that step, you probably ought to put a star by it and multiply out or something, because I guarantee you that step would cost you on a test. Okay, so anyone else have a question or on that one? Okay, all right, great. So the hardest one of these is case 3. And case 3 is where they're both even. Okay? And when they're both even, see, there's nothing to peel off. So what you're going to do is use the power reducing formulas. So sine squared equals 1 minus cosine 2x over 2. Cosine squared is 1 plus cosine 2x over 2. Or, you see how I've written it here in red and blue? Is usually that's going to be how you'll use it when it's squared on one side. Okay, now all right, so let's just look at this one together. All right, so using see again, what you're looking for is, man, it would be great if one of those were odd, and then we could peel it off and use U substitution, but it's not. So in this case, rewrite each of those in terms of using the power reducing formula. Okay. All right, now, so before we integrate this, we want to FOIL these together. Now, one little trick is, see where these have a 2 here? The bottom? If you pull out the 1/2 from each of those, then you can get 1/4 1 minus cosine 2x times 1 plus cosine 2x. Now, we still can't integrate that yet because these are multiplied together. So we need to FOIL this out. So when we FOIL these out, what will we get?
It would be 1 minus cosine squared 4x.
Yes. Well, no, it'd be 1 minus cosine squared 2x. Because, see, if you just had cosine 2x times cosine 2x, or let's come over to the side here. So if I have cosine 2x times cosine 2x, see, that would just be cosine squared 2x. You don't multiply the arguments together because that's what cosine squared means, is you're multiplying the two cosines together. Okay. It's just like if I had cosine x times cosine x, it would be cosine squared x, not cosine squared x squared. Does that make sense? So okay. So we get 1 minus cosine squared 2x. Okay, now we can integrate the 1 here, but we still have trouble with this cosine squared 2x. So what we have to do is use the power reducing formula again. So, see, let's go back to, so 1, okay, so you got to think, so what would cosine squared 2x, if you use the power reducing formula, what would that end up being?
What?
1 plus cosine 2x.
Close. But what happens to the argument as you reduce the power? What happens to the argument of cosine?
Would it double?
It doubles. Okay, so it's going to be 1 plus cosine 4x over 2. So the angle doubles when you reduce the power, and then you've got the division by 2. Okay, now actually we know how to integrate this. Okay, so I just kind of want to see what kind of algebra you might do. So just see if you can finish this one off. So it's the integral of 1 minus, here, let's write that a little clearer here. So we have 1/4 out front, and then the integral of 1 minus 1 plus cosine 4x divided by 2 dx. Okay, so see if you can integrate that. All right, so Aiden, when you've got it.
I got 1/8 times x minus sine of 4x plus c.
1/8 x minus sine of 4x. Okay, so it's when you do the integral of cosine 4x, it's sine 4x divided by 4. So whatever the k is, where the coefficient of x, you have to divide by that. And so then that's going to be, so then if you distributed it, it would be 1/32 sine 4x. Did you say 1/8 over here? And I maybe you said this over 4.
No, I didn't.
Okay. So that's whenever you're integrating like sine of 3x, it's cosine 3x over 3. So, because remember when you do the derivative, the chain rule says you would multiply by that 3. When you're doing the integral, you divide by the coefficient. Okay?
Could you scroll up a little bit, please?
Sure. So what I did is I separated this fraction so that I could combine the 1 minus a half and only have a half. And then I actually pulled the 1/2 out front so that's the 1/4 becomes 1/8. Okay. All right. Any questions on that? Okay. So now eliminating the square roots. So this is, we're going to use the same like power reducing formula. So usually you see it's cosine squared x equals 1 plus 2x, 1 plus cosine 2x over 2, or 2 cosine squared x is 1 plus cosine 2x. So just divide it, multiplying each side by 2. So you might use either the same, it's the same formula, just a different variety of it. And then, so sine squared, so what's the difference with sine squared? So sine squared x, it almost is the same. What's different about it?
It's 1 minus cosine 2x.
Yeah, so it's 1 minus cosine 2x over 2. Okay, and so if so that would be the same thing as 2 sine squared x, or 1 minus cosine 2x. Okay, I know I'm giving you the same formulas again, but I just kind of want you to see it. So just looking at these, so now let's turn the page and look at practice 4. So which one are we going to use? So 1 plus cosine 2x, what's that going to be?
Two cosine squared x.
So, okay, so when it's plus, it's cosine. So so it's 2 cosine squared x. Now, the whole beauty of this is because now the square root of cosine squared is just going to be cosine, which we know that integral. The radical 2, that's just a constant. So you can actually pull that out front. So pull the radical 2 out front, and then the square root of cosine squared is just going to be cosine. So see if you can finish this one off. All right, so Jordan, I haven't heard much from you today, so when you've got it, let me know.
It ends up as 1.
It ends up as 1. Good job. Okay. Any questions? Anybody need me to go through it?
Yes, please.
Okay. So when we get to the square root of cosine squared, that just becomes cosine. The radical 2 we brought in front. So then the integral of cosine is just sine. So we have the radical 2 out front. The limits of integration are from 0 to pi fourths. So now we plug in the pi fourths minus when we plug in the 0. The sine of pi fourths is radical 2 over 2. The sine of 0 is 0. So then we just get a radical 2 times radical 2 is 2 over 2 minus 0. So 2 divided by 2 is 1. All right. Any questions on that? All right. Good job, Joran. Okay, so integrals of powers of tangent x. To integrate powers higher than 2, you're going to use the identity tangent squared equals secant squared x minus 1. Or secant squared x equals tangent x squared plus 1. And then sometimes you have to integrate by parts on these. Sometimes you can just do u substitutions. All right, so okay. So just kind of copy this down for practice 5. So here what we're going to do is peel off one of the tangents. Okay. Now, the reason we do that is because, see, now the even powers of tangent, we're going to use that Pythagorean identity. So secant squared x minus 1. So it's very similar to the idea with the sines and cosines. Okay. Now, when we distribute, you have, actually, let's write it as, well, okay. So integral of tangent times secant squared x minus tangent x. Okay, now, this one we can do by u substitution, because here, if we let u be the tangent, well, okay, so here I'm separating them. I'm thinking of them as two separate problems. So here, if I let u be the tangent, then du is secant squared. So it's great when I have a tangent and a secant squared together. And really tangent of any power. Okay? Now, the integral of tangent we actually did in chapter 7. And so you might have that written down somewhere. But it's actually ends up being a natural log. So it's the integral of tangent x is the negative natural log of secant x plus c. Okay, so you don't have to go through that. We did that already. Okay, so here we have the integral of u. Du is u squared over 2. And so then you plug in what u was, and that's our final answer. So tangent squared x minus the natural log of the absolute value of secant x plus c. Okay, so see if you can do practice 6.
Wait, Mr. Strong.
Yes, please.
Can you go through this one again? I got lost and I'm really confused.
Okay. Well, it's part of it is kind of looking at the So, like where we wanted to have peeled off a sine or a cosine. See, with the tangents and the secants, what we want is a secant squared peeled off. Because the derivative of tangent is secant squared. So if we have tangent to any power times secant squared, we can do it. Okay? So when we peel off two of these tangents and then get a secant squared here, we're going to be able to do it. Okay? So let's just look at practice 6 here. And just kind of look at one fresh here. So we have secant to the 4th. So what we want is two of the secants by themselves. So peel off secant squared. Okay, so then we would have secant squared times secant squared. And we'll come back to this one if you want. Okay, so we're going to peel off two of them. So that we have secant squared times secant squared. So one of them I'm going to leave because I want that as the du, the derivative of tangent. Okay, the other one I'm going to write it in terms of tangent. So secant squared is what in terms of tangent? How can I rewrite secant squared so that it's in terms of tangent?
It's tangent x squared plus 1.
Okay, so tangent squared x plus 1 times secant squared. Okay. All right, hold on just a second here. Sorry. Okay, so now if I say, okay, I'm going to let u be tangent x, and I'm going to let du be secant squared x. Okay? So then when I did the u substitution, what would I end up with?
You get u squared plus 1 du.
Yep. So u squared plus 1 du. Okay? So do you see, so Jordan, the reason why I peel off two of the secant squared is because that's going to be my du. That's going to be the derivative of the tangent. And so your u is going to be tangent. So now this is u squared plus 1 du. Okay? So now what's that integral? What's the integral of u squared plus 1?
U cubed over 3 plus u.
Right. And so then you say, okay, u is tangent x. So you plug that in, and that's it. Okay, so try practice 7 now. And there the secant squared is already peeled off. It's already separated for you. All right, so David, when you've got it or when you get stuck, let me know.
I got tangent to the 6x over 6 plus c.
Nice. Okay. Any questions on that? All right.
Could you just leave it for 1 second?
Yeah, sure.
Thank you.
Do you need me to explain it, or are you good?
So you just don't have to change it. You just have to use substitution, basically.
Yep.
Okay.
Yep. Because you already have a secant squared already set apart on this one. Okay, so the last part we're not going to be able to finish, but if you could just write down, these are the integrals types, and these are the trig formulas we're going to use to solve them, the angle sum formulas. And I'm going to just tell you the calculus is way easier than the trig on this. It's actually, the calculus is going to be pretty easy once we figure out which formula to use. So tomorrow I'll just start off using the formulas with an example and then the practice. It will be easy. We'll do it in less than 5 minutes, and then we'll start in on 8-4.